In this video, we will generate the dataset of the standard logistic function and the regression coefficient and its trend line. We will also generate the Taylor-Maclaurin series sum and its trend line as well. So we begin with the dataset. So array formula, exponent of the x values. And you see our trend line. But this is only the exponent. So we add in the negative sign and factor in 1 plus. So 1 plus and this will be the numerator. So here you have the standard logistic function. Next, we generate the Taylor-Maclaurin series sum. We begin with the summation, which is e to the minus x is equal to the summation of a times x to the power n, where the value of a, the coefficient, is negative 1 to the power n over n factorial, where the values of n will be from 0 to infinity. We try to get to infinity, but we'll just go for 12 maybe. Then that will be the value of our n values. So let's start with the Taylor-Maclaurin series sum. If you start with this, the summation of a times x to the power n. So array formula, series sum of x to the power n. That is x to the power 0, starting with 0, incremented by 1. And the coefficients will be this range. Next, we work on the coefficients. So with this array formula, let's start with the numerator. That is minus 1 to the power n. Then we follow by the denominator, which is factorial n. Factorial of n. Now we're getting close. Now we will make changes to our Taylor-Maclaurin series sum. So this is 1 plus the summation. So 1 plus the summation, the series sum. Next, this would be this is the denominator, so we add in the numerator. So 1 over 1 plus the series sum. Now they're on the same line. And their values match closely up to here. But there's a bit of an error as you go farther from 0. And our trend line equation, they're on the same trend line. Next, we generate the regression coefficients. To do that, we complete the 1 comma x matrix. So our 1 comma x matrix allows 0 degree of freedom because the number of rows equals the number of columns. So this will be transpose from 0 to 6. That means the number of rows will be the number of, equal to the number of columns. That means 0 degree of freedom. Now the 1 comma x matrix will be array formula of the x values raised to the power 0 to 6. Now that you have the 1 comma x matrix, we can enter the LINEST. So LINEST, starting with the function is a standard logistic function. Data y and data x. And the Taylor-Maclaurin series sum, which is or the expansion, that is LINEST of data y and data x. So let's compare our values, the regression coefficients, with the ones in our trend line. Our B 0.5 matched our trend line. Our B 1.247 matched our trend line. Our B2 is 0 because this is very small. This is considered 0. So they match our trend line exponent negative 17. So that's already uh, very small, considered 0. B3 is 0.017, negative 0.017. They matched our trend line. B4 is 0. Here, 1.25 times 10 to the minus 6, that's already 0. And B5, 7.06 times 10 to the minus 4. They matched our trend line. And B6, 0. 2 point, negative 2.5 times 10 to the minus 7 is already 0. So this completes the regression of the standard logistic function to LINEST polynomial regression of degree 6 and the generation of its Taylor-Maclaurin series sum expansion.